So hello and welcome to the continued coverage of the walkthrough series, and in this episode we are going to be looking at the summer 2025 variant 41 for 9618, and in this episode we are doing the Python implementation for question 1 of this paper. So without further ado, let's actually just go ahead and jump right in and see what we have going on here. So let me just zoom in so that you can see the questions a bit better. So here we have the preamble, right? With the information telling you how you are going to save your document and everything else. Then if I toggle here and open my file browser, you actually see that I have the source files that I mentioned here as the txt files, and I also have the evidence document there. But I'm not going to be using it for this particular video. Then of course we have our Python file right there. So here we have question 1. Let's see what's going on in question 1. So here we have a program that's going to store positive integers in a circular queue. The queue is stored as a global 1D array of 20 integers with the identifier q. Each index is initialized with the data -1. Then we have three global variables going on there that are initialized to these values, -1, -1, and 0. So our task on part A is to write a program that declares and initializes these variables, as it were. And for that, we are going to be awarded 2 marks. So let me just switch to the code here and show you the way I went about it. Let me just zoom in a little bit so you can see the code a bit better. I think this is sufficient. Let me just close out of the file explorer there. So number 1 here, it's going on from lines, including the comment, lines 1 to 5. So you actually see that we are declaring the queue and we are initializing it with a value of -1. And this syntax that we're using on line 2 there is to simply say that for this particular list, remember in Python, whenever you can't, you can always use an array or a list, but a list is more flexible for this particular question. So we're using a list, and we are initializing the list with a value of -1, and we are multiplying that by 20. So this simply means that we have a list of 20 elements that have a value of -1, or that is 20 elements initialized to a value of -1. Then the head pointer, tail pointer, they both have a value of -1. And the number of items is currently 0 because we have nothing going on in the list there. And for this, we would get 2 marks according to the question here. So you actually see that we have 2 marks here. Then, of course, you are going to copy this code and paste it inside of your evidence document, as it were. All right, so moving on to the next question, we have part B, which says that the function in Q does those things. So it's going to take an integer as a parameter. It's going to check to see if the Q is full. Then it's also going to return false if the Q is full. Otherwise, it's going to store the parameter in the next position in the queue and returns true if the queue is not full. Then it's also going to update the appropriate pointers in number of items, as it were, or number of items rather. Then for this, we are going to get 6 marks of this implementation. So let's go ahead and look at the implementation that I have going on here. So from line 7 to line 20, that's where I'm implementing my enqueue function. So the function here on line 8, you see that we have the name enqueue, and we have a placeholder for the value that we are going to pass as a parameter, and we just call it value. Right? Of course, we could have named it anything else really, but I just went with value for this particular example. Then on line number 9, we have the global keyword. So what this does is that it's going to tell this function, or rather it's going to tell the Python interpreter that for this particular function, these variables called q, head pointer, tail pointer, number items, you're going to refer to these global variables right here, right? These variables are called global because they are declared outside of any function. So anything else that you would declare inside of a function is a local variable, but anything that resides outside of a function is a global variable. So for this particular example, rather for this particular question, we have these global variables. So in order for the Python interpreter to know that it has to make use of this q, this head pointer, this tail pointer, and this number items, is we have to use the global keyword, as it were. So that's how it's going to work. Then we were asked to return false if the queue is full. So what we are going to do on line 11 to 12, rather 11 and 12, we are checking to see if the number of items is equal to the length of the queue. So let's say if our queue has a length of 20, like in this case, if the number of items is equal to 20, it means that our queue is full. So it means we are not able to enqueue any items. So we are going to return false as an indication that there's no space on the queue, as it were. Then we also need to, in the event that we still have space, we need to be able to store the parameter in the next position in the queue. So what we are doing is we are taking the value that was passed to the enqueue method right there. Then we're also going to set the head pointer to, from -1 to 0 because we are now moving our, we need to update our head pointer because we are going to add a value, is it? So essentially we are using the, for secular queues, they use this technique of wrapping the index positions, etc. If you enqueue an item, so that's what we are doing on line 17 there. I have a video in which I did the animation and explanation for the secular queue, so you can go ahead and check that out. It's also here on my channel. I go into more depth about how a secular queue works, but essentially we are just using the modulus operator to wrap our queue on line 17 there. Then we are taking the value and storing it at the current tail pointer, because remember, when you add a value to a queue, it's going to go to the tail, as it were. Then we increment number of items by one and return true at the end right there. So for this implementation, we are going to get 6 marks. So you would of course go ahead and copy your code and paste it inside of the evidence document. Let's move on to look at part C. So it says here that the main program is going to attempt to store each of the integers 1 to 25 inclusive in the queue, in ascending numerical order using a queue. So for that part, what we're doing is we have the queue, and we are now making use of the enqueue method. So what we are doing is we are using, since our data is ascending, right, that is 1 to 25, we can just use a loop and the range function, is it will, so that we specify that for the numbers in range of 1 to 26, right, rather 1 to 25. So you need to remember how the range function works in Python. The range function, it starts at the position 1 up to but not including the end position. So this means that we are going to end at 25. It's not going to include 26. So that's how we are going to have values that range from 1 to 25. Then essentially what we are doing is we are just taking the current value of I and storing it as the result. Then and then queuing it rather. Then if we are able to enqueue that value, remember that enqueue returns a boolean true or false. So in the event that we enqueue an item, it's going to return a true. Then in the event that we are unable to enqueue an item, it's going to return a false. Then on line 27, we are using the ternary operator, as it were. So essentially how this works is this. We have, if this is successful, right? If Boolean result is successful, we are going to execute the code on the left. Otherwise, we are going to execute the code on the right. Is it? So that means to say if result is false, then it's going to execute, rather print unsuccessful. Then if result is true, then we are going to print successful. Then of course, we are just format printing so that when we output in the console, we are going to specify the element. Let's say the element was 1, we're going to say 1 successful, and so forth and so on. Then, so this is what we are told to do, that if the integer 5 is passed to enqueue and is stored in the queue, the output will be 5 successful, right? Then if it's 23, then it's going to say 23 unsuccessful. So that's what we are doing on line 27 there. Then we would of course go ahead and copy our code and paste it inside of the evidence document, as it were. Then moving on to part D, we have the function dequeue that returns a -1 if the queue is empty. If the queue is not empty, the function returns the next item in the queue, based the appropriate pointers and updates number items, as it were. So we are supposed to write code for the dequeue function. Then let's go ahead and look at the implementation that I have going on here. Again, much of this you've seen it earlier on in the enqueue method. We are referring to the global variables that we've declared at the beginning of the script, and we are checking to see if the number of items is 0, meaning to say that our queue is empty, so we cannot dequeue a queue that is currently empty. Otherwise, we're just going to go ahead and add an item, as it were, because dequeue is going to remove the item that is at the head. So we're going to take the item that is at the head and set it to -1. That is to say that there's now nothing at the head pointer. Then we are also going to use the modulus rep technique right here. It's more or less the same as this one that you saw earlier on in the enqueue method. Again, you can always refer to my secular queue animated video. It's also here on my channel. Then line 43, we are decrementing the number of items by 1 because we have removed an item from the queue. Then we are also going to check to see if after removing that particular item, if the number of items is currently 0, we are going to set the head pointer and the tail pointer to -1. So essentially, the head pointer and the tail pointer are going to point to the same position, as it were. Then ultimately, we are going to return item, is it? So DQ is going to return an item, as it were, because that's what we were told here. It returns -1, otherwise it's going to return the next item right here in the queue. So that's what we are going to do here in the end on line 49 there. Then moving on to part E, write program code to extend the main program to call DQ twice and output the return value each time. Then we are going to write that piece of code. So coming back to my main method here on lines 29 to 31, we are calling DQ twice, is it? Again, we have format printing or F printing as it is called in Python. So we DQ'd, then we are going to specify the element that we have DQ'd. Remember, DQ is going to return an element. So let's say we had 15, so it's going to say DQ 15. And if you DQ another element, it's going to be DQ'd, then there's going to be 14 here. Is it? So that's how it works. Then, of course, you'd go ahead and copy this code and paste it inside of your evidence document. Then the final part of the question says here that test your program, take a screenshot of the outputs. Then you are supposed to copy your screenshot. You're supposed to screenshot your output and save it in the evidence document. So let me just go ahead and make sure my console is clear. My console is clear. So I'm just going to be hitting the play button here because I'm too lazy to type today. So let me just click on this one. And you actually see that we have our output here, is it? So this is my Python script being executed right here in blue. So you see that from 1 to 20, we were able to successfully enqueue our items. But starting from 21 to 25, we were unable to enqueue these items. Why? Because our queue, if you remember from the global array, from the global list here, it only stores, or it only has space for 20 elements. So we are only able to store from 1 to 20 inclusive. Then from that point onwards, we are not going to be able to save anything. So let me just clear out the code. So I think I have 2 outputs. The previous one was for when I tested the program, when I was doing it on my own. So let me just cycle that command here. So yeah, there's our output again, right? So you of course go ahead and copy this code and paste it inside of the evidence document, as it were. Then of course, yeah, the DQ'd part. This is where we call the DQ'd part, the DQ'd function 2 times. So that would be the end of question 1 and also the end of this video. So yeah, hopefully you learned something, and see you guys in the next one.